Welcome to the Aspen Plus Intermediate Process Modeling course by Chemical Engineering Guy. So we're going to cover in this video what is on the course, an overview, very overall overview. So this course is split up into 7 sections. Each section is very important, but I will say that the most interesting part will be 4, 5, and 6. Because these are not so critical, or what I want to say is that this is not that important if you have been taking some courses on Aspen Plus. So we start with the introduction section, which is this one. We're going to see the technical requirements, who's this course for, what are you going to learn, and so on. A little bit on Aspen Plus, technical data, and then we continue with section number 2, which is flowsheet manipulation. We're going to increase our, let's say, knowledge on how to manipulate the flowsheet in order to show different figures, move different block units, and so on. The physical property environment, we're going to cover a little bit more on that because on the last course, the basic course, plenty of people wanted to see more on physical properties. We're going to cover some. And then we continue with the interesting part. We are going to cover more unit operations, more complex or rigorous ones. Then we go to the model analysis tools in order to increase our simulation techniques. And then we put all these blocks into practice on the case studies. Finally, we make a small conclusion, what we learned and what's coming for future courses. Let me show you a little bit on section number 2, flowsheet manipulation. And as the name implies, we're going to be, let's say, playing more with the flowsheet. And we're going to use also the famous hierarchy blocks, which is essentially a sub-flowsheet. We're going to be using the section right here, which is flowsheet, and you have this type, which is called modify and format. We're going to be using mostly modify. For instance, rotating, flipping, breaking, reconnecting, rerouting streams, and so on. Also how to find new objects, how to modify formatting, spacing, figures, how to show temperature, pressure, vapor fractions, flow rates, and so on. Also a little bit on how to log flowsheet and how to work with the hierarchy block, which is right here in Manipulators. Hierarchy is a very unique one because it is actually a, let's say, a manipulator, but I like to call it much similar to a template. You build up, let's say, a reactor, which you know you're going to use in several simulations. So you save this reactor as a template, technically as a hierarchy block, and then you can input it or add it in many flow sheets. So that's very useful. Now we continue with section number 3, physical property environment. You've seen previously in the basic course, we cover very little the physical property environment because this is much more into thermodynamics and transport properties and so on. We're going to cover more on what is a method, how to select the method, more on property sets, select the relevant variables we want to use for our analysis. This NIST thermodynamic engine, which is a database, very powerful one, in which we can get raw experimental data. And finally, some analysis tools, especially the binary tool, the pure component tool, and so on. Section number 4 is much more into our actual course, is going to be analysis or learn more about unit operations. And we have these right here. I usually separate them as separators, heat exchangers, let's say columns, reactors, and pressure changers. Separators are typically the flash or for 2 phases or 3 phases, decanters, and raw separators. We're going to see some exercises. Each one of them has a small workshop. Heater covers mostly how to use our rigorous phase heat X or the, let's say, typical heat exchanger, which has two fluids. We all know that one is the cold fluid and the other one is the hot fluid, and how to use, let's say, control flow rates and so on. The columns, we are going to check out more on radfrac, also in extract, and how to model absorbers or strippers. Then we continue with the reactors, more rigorous design. Previously we saw the R stoic, which is based on the stoichiometry, and R yield. Now we're going to check out more on the equilibrium and Gibbs free energy, which uses the equilibrium constant. Also RCSTR, remember that this is the continuous stir tank reactor. You have this tank right here, which is actually a reactor. You have A, let's say that A is converted to B, and this is continuously stirred. Or the R plug, which is the plug flow reactor. Many times we only have a pipe, and we know that they will react. So we have A plus B. At the given conditions, they start reacting, and the C goes out. Finally, pressure changers. As the name implies, these operations or unit operations are used to modify pressure. The pump, compressors, we're going to see much more on compressor curves and pump curves. Valves, how to interact valves, and with pipes, the size of pipes, schedule 40, 80, and so on. Now, section number 5 is about analysis tools, and it is much more on the analysis that we can do on our existing simulations. How can we optimize them, improve them, select specifications, and so on. We start with the obvious one, which is getting results, how to get much more relevant results, report them in a much more efficient way. Also, we learn how to plot data. Many data, actually, not only on unit operations, but on flow streams and so on. And these three guys are the important ones. The design specification, how can we select a specification and change all other, let's say, inputs in order to favor our final specification. Let's say that we have a mixture here, let's say X, and we require 99% of purity right here. Well, instead of actually guessing for temperature, pressure, the relationship of the feed, the duty, and so on, we are going to select this design specification, and we will get fixed all this by Aspen Plus. Sensitivity analysis, well, as the name implies, we're going to verify how sensible is our process as we change different properties or variables or inputs. So let's say we wanted to analyze a distillation column, we have it here, and we want to see the effect on changing the feed stage. Instead of actually changing manually feed stage number 1, stage 2, and so on, maybe we only have 10, it's okay, but if we will have maybe 30, that will be really a pain in the ass. So this is much better. We use sensitivity analysis, and instead of actually running by one by one, we just select the sensitivity analysis, select the variables that's going to be changing, and verify our purity. Maybe you want to verify the reboiler duty, or maybe you want to check out the efficiencies and so on. You can do it this way. Finally, optimization and constraint. As the name implies, this one is used in order to maximize or minimize, that is optimization, a property. And as you know, guys, many times we have constraints. So let's say what will be the maximal input if we have the constraint of the 99%. So let's say how will be the minimum requirement, or what will be the minimum requirement of a compressor. You can check it out here. And we continue with our case studies, section number 6. We are going to be working with these 3 case studies. They are different or separated. Hydrodealkylation of toluene. So toluene, you know, this is a benzene ring and has a methyl. We're going to convert it to benzene. No, of course, you know, this is the hydrodealkylation. We are releasing this alkyl. Then the benzene ring converts to diphenyl. Of course, as you might think, there are reactions, therefore we need reactors. Nitric oxide plant, we're going to produce some nitric oxide and isobutane production from isobutane. So we want to increase the quality of the raw materials. So isobutane, you know, this is something like this. Isobutane should be something like this. Typically used for many other applications in the petrochemical industry. And final section will be section number 7, in which I will conclude the, let's say, the course. We're going to make a wrap up, what we learned, and then I will recommend you what course can you take, what will be the recommendation, what can you do in order to increase your Aspen Plus software knowledge, and so on. And last but not least, you will have some bonuses, maybe some audio, extra audio, some documents, and so on. So see you in the next video, guys, and I hope you really like this course.